Hello everyone, I am Ümit Alkuş. In this video, we will solve one problem in chapter 12. In the figure, the mass of the signboard is 13 kilograms and that of the beam is 6 kilograms. The supporting cable is assumed to be weightless. Calculate A. The magnitude of the tension force in the cable. B. The magnitude and direction of the force exerted by the wall on the beam at point P. Since the system does not rotate, then the net force about P is 0. According to the following figure, torque is defined to be Rho times F perpendicular, where subscript O represents the point through which the rotational axis passes, and F perpendicular is the component of the force perpendicular to the line of extension of position vector Rho. According to the figure, we take the positive and negative rotations as follows. Then the net force becomes A times Ty due to the string minus A times capital M times G due to the signboard minus A over 2 times mg due to the beam. As you see, the torques due to Fx and Fy are 0. In this equation, A's are cancelled and these terms are taken to the left-hand side. So we obtain Ty as capital M plus M over 2 times G. If we substitute the corresponding numerical values into this equation, we obtain Ty as 156.8 newtons. From the figure, Ty over Tx is tangent theta, and it is B over A. With the numerical values, we obtain 1/3. So Tx becomes 3 times Ty. We know Ty, so Tx becomes 470.4 newtons. From the Pythagorean theorem, we find the magnitude of the tension force with the formula square root of Tx squared plus Ty squared. Insert the numerical values into this equation, and the magnitude of the tension force is calculated to be approximately 496 newtons. In order to find the force exerted by the wall on the beam at point P, we use non-moving conditions F net equals 0 because the system is in equilibrium. Therefore, the net force along the x-axis is also 0, which is Fx minus Tx. Therefore, Fx is equal to Tx, and it has the magnitude of 470.4 newtons. The net force along the y-axis is also 0, which is Fy plus Ty minus mg minus capital Mg. Then Fy becomes M plus capital M times G minus Ty. With the numerical values, we obtain 29.4 newtons. From the Pythagorean theorem, we find the magnitude of the force as square root of Fx squared plus Fy squared. We substitute the numerical values into this equation. Then we obtain approximately 471 newtons. The direction of the force is found by the formula arctangent Fy over Fx. With the numerical values, we obtain approximately 3.58 degrees. Okay, this is the end of the discussion of this problem. Thank you for your attention. See you in the next video.